This is lesson 12.1, trig ratios, part 2. Our objective for today: I can use the inverse sine, inverse cosine, and inverse tangent function to solve for an unknown in a right triangle. When you are given two sides of a right triangle, you can find the measurement of the missing angle by using trigonometry. This is called inverse trigonometric functions because you are undoing your trig steps to solve for the missing angle. To solve for the missing angle, we will have to use inverse. So if it's inverse sine, it looks just like the lesson before. Sine, only it looks like a -1. That means inverse sine of O over H. That will give you the angle. So theta equals angle. There's a button in your calculator, again, if you're having trouble finding it, just let me know, where if you press second on your calculator and then sine, it will give you inverse sine. So that would also work for cosine and tangent. Again, if you're having trouble, just let me know and I'll help you find it. Inverse cosine, so that's ca, so cosine with the inverse there. Cosine equals A over H, ca. That will give us the angle that we're looking for, which we'll just call theta. And tangent is TOA, so tangent, inverse tangent of opposite over adjacent, because TOA equals the angle we're trying to find. So we'll do a couple problems and we'll set it up just like we did in the lesson before. To complete an inverse trig problem, you set the problem up the same as you normally would and then undo the trig function by using the inverse. So example 1, we start with our angle. This is what we're actually looking for. We go straight across. This is the opposite side. I have information there, so I'll use this side. Look for the right angle, go straight across. This is the hypotenuse. There's no information given there, so I won't use that side. And then left over is adjacent, which it does give us information, so I'll use that side. So I'm going to be using O and A. O and A means TOA. And so we set it up just the same. So tangent of our angle, which in this case we don't know, so I'll just write theta. Tangent of theta equals OA, so O over A, 26 over 45. And then we want to have theta all by itself on the left side here. So to get rid of tangent, it's basically like you do inverse tangent, kind of on both sides, you could think of, if that helps. So then that would be gone and we would be left with theta equals the inverse tangent, this is how we'll write it, of 26 over 45. So that's how you'll type it in your calculator. Inverse tangent, 26 divided by 45, parenthesis, enter. To do that, theta is about 30. And look where theta is. It's right here, which is an angle, so that means degrees. Alright, let's give the next one a try. Here is our angle theta that we're trying to find. We go straight across from it to the opposite side. I do have information there, so I'll want to use it. I look for the right angle. Straight across from that is the hypotenuse. I have information there, so I'll want to use that side as well. And then whatever is left over is the adjacent side next to the angle. I don't have any information there, so I don't want to use that side. So I'll be using O and H, which means so. Sine of theta equals opposite, which is 48, over the hypotenuse, which is 105. We want to get theta by itself here, so we need to get rid of sine. So theta equals, if I take the inverse of both sides, so inverse sine of 48 over 105. Type it in the calculator. Theta is about 27 degrees. Okay, start out. Here is theta. That's the angle I'm trying to find. Straight across from it is the opposite side. No information is given to me there, so I won't be using O. Look for the right angle. Straight across from that is the hypotenuse. They give us information there, so I'll want to use that side. And then left over is adjacent. They did give me information there, so I'll want to use that side. So it looks like we will be using A and H, which means ka. So cosine of our angle, which is theta, equals A, which is 37, over H, which is 78. Now to get theta all by itself, I want to do the inverse cosine on both sides. So theta equals inverse cosine of 37 over 78. You go ahead and type that in the calculator just like the way I wrote it. And theta is about 62. This is an angle, so degrees. Alright, start it off by labeling your triangle. Here is our angle, so straight across from that is the opposite side. Look for the 90-degree angle. Straight across from that is the hypotenuse. Both of these sides have information given to us, so we'll want to use both of those. Let's still label the last side as adjacent. No information was given, so we won't use that side. We will use opposite and hypotenuse. The only one that has both O and H is so. Alright, started off sine of our angle, which we don't know, so theta equals O over H. O is 64 and H is 84. And now we need to figure out what theta is, but right now it's sine of theta. We want theta to be all by itself. If it helps, you can think of draw the line down, and you could think I'm going to do inverse sine on both sides. If it helps you to balance, that's totally fine. So then theta equals inverse sine. You have to have this part written first and typed in your calculator first. You can't have it afterwards or it won't understand what you're looking for. 64 over 84. You should just type it in the calculator just like I write. Alright, so inverse sine of 64 divided by 84. So theta is about 50 degrees. When doing these problems, I always write SOHCAHTOA at the top of my paper, so when I do the homework and any of those problems, I recommend writing down SOHCAHTOA at the top to help us. Okay, example 7, here is our angle. Straight across from that is the opposite side. There's no information given, so we're not going to use that one. Look for the right angle. Straight across from that is the hypotenuse. They did give us a number, so I'll want to use that side. And then left over is the adjacent side. It's right next to the angle. They did give us a number, so I will use that side. So we will be using A and H. And we look over here for the one that has A and H, which is ka. So that says that cosine of the angle, which we don't know, it's called theta, is equal to A over H. And A is 14 and H is 22. Again, if it helps you to just do the balance, that's fine. To get cosine to go away, I do inverse cosine. So then theta equals inverse cosine of our fraction 14 over 22. So theta equals, well, that's about 50 degrees. Last one. Here's theta. Straight across from it is the opposite side. They gave us information, so we'll want to use that side. Then we look for the right angle. Straight across from that is the hypotenuse. No information given there, so we won't be using h. And then last, right next to it is a, the adjacent. They gave us 38, so we will be using that side. So we are going to use a and o. The only one that has a and o is TOA, so we will be using tangent. So the tangent of theta equals the opposite, which is 57, over the adjacent, which is 38. So then to get theta by itself, we do the inverse tangent. So theta is equal to the inverse tangent of our fraction 57 over 38, which in your calculator is just divide. Just use your parentheses. So theta is about 56 degrees. And this concludes lesson 12.1, part 2.